So hello everyone. Hope you're doing good and welcome back to my channel. Today we are at day 19 of the April Daily Leetcode Challenge. And congratulations to all those who have maintained their pace till now, who have been facing all the challenges and have the courage to solve them, or at least seek for the solutions even if you're not able to do it. So congratulations to all those. And now coming to today's question, we are at question 1372, longest zigzag path in a binary tree. Okay, let me tell you my specialization is binary. So if you have any doubts in this question, please do comment below because I take them as a challenge. Right now, coming to today's question, we are given a tree with see, we are given actually the root, and this is the data structure for the tree node. Okay, so if you are a beginner, you will not be knowing these things. So let me explain this first. You are given a root, and this is the data structure which it follows. Okay, so every node will have a left and I will have a right. As you can see here, a root will have a left subtree and have a right subtree. Similarly, this. Okay, and each will be a root in itself. Okay, each subtree will have a root in itself, and it will continue. Okay, it will have a value. It will have a left pointer. It will have a right pointer. Okay, so that's how the structure is. Just go through it once, and we are given the root of it. So the root here has a data type of this. So root is basically an object of this particular class, right? So now this was all about how LeetCode gives the question, and now coming to the question. See, in this particular binary tree, we have binary means it will have at most two children. Okay, every root will have at most two children. It can have one or zero as well. So coming to this question, we are asked to path the longest zigzag path. Okay, the question is very clear here. Longest zigzag path. So what it means is, see, they've clearly given some definitions here. You can choose any node in a binary tree and a direction. You can follow the direction with its right. Let me give you the example here. That will be better. Okay, what you can do is you can select any node and then a direction. For example, I'm selecting this one which you are seeing here. Okay, and then I'm moving right. Okay, I could have moved left also, but you can see left. If I move, I will have to stop. So the maximum length possible is this. And one more thing they have given here is the zigzag length is defined as the number of nodes visited minus one. Okay, number of nodes visited minus one. And please remember this point. In example 3, this thing I will again remind you. A single node has a length of 0. Okay, so number of nodes, so zero length is defined as number of nodes visited minus one. Okay, remember this. So if I have taken a left from this particular one, what will be the my zigzag length? It will be 2 minus 1, which is 1. Okay, you can say that answer is going to be the edges between the nodes. Okay, then edges which you have traversed. So in this case, one edge, so it is going to be 1. Now suppose I've taken right from here, what will the length? See, this is the thing. I'm taking right, again I'm taking left, I'm taking right. Okay, so zigzag means you have to take a right, then you are compulsorily you have to take a left, then again you have to take a right. Okay, now when I am at this right, I cannot take a left, there is no left. Okay, when I'm this particular one, there is no left possible, that's why I'm stopping here. So if I calculate from this one and to the, see, if I start from this one and take a right, the maximum length which I'm going to get in this case is going to be 3. Why 3? See, the edges you just count. Or you can say number of nodes minus 1. In this case, 4 minus 1, 3. Okay. See, is it? I'm not stopping here. There is no other way. That's why I have to stop here, right? Similarly, when I start from this one, okay. Now, suppose I start from this one, okay. You will say, why I'm not starting from the root itself? See, I'm starting from the root. I have to take a right, okay, because there is no left here, right? There is no left. I have to take a right, and when I take a right, I have to take a left in the next turn. So you can see I'm forced to stop here. Okay, I'm forced to stop here. So what is the length of the maximum path? If I start from the actual route, it's going to be 2. Okay, let's say if we start from this, we are going to get a bigger length, which is 3. Okay, now you will say, why can't I start from this particular one? Okay, this one. If you are able to see here, this one, let me trace this as well. Okay, if I take a right from here, from this one I am starting. Okay, if I take a right, I am forced to stop here, so the length is going to be 1. Max length is 1 in this case. If I take a left, what is the thing? Left here, then right here, then I'm again forced to stop, so the max length will be 2. So you can see, whatever we do, the maximum length is going to come from this path only, and the maximum length is 3. Okay, so see, the important part of this example is the answer need not start from the actual root of the tree. You can clearly see this is the highlight of this example. In the next example, you can see the answer is starting from the root of the tree itself, but in this example it was not like that. Okay, so make this one very very clear, because see, in today's example, in today's code which I'm going to show you, it will not be able for me as well to show you how it happens, because see, this I have coded by seeing every example. Okay, I have faced challenges and I have how to overcome them, I have done, and I have got to this code. You can search this code anywhere, you will not get, you will you will get a clarity that this code is not been copied from anywhere. Okay, I've developed this code on my own, right? So I will give you this code. You will have to comment out the things and you have to run and you have to understand how it works, right? It will be difficult for me to trace and show in without a pen and paper, right? Now coming to the example two of it, you can clearly see just follow the blue path. Okay, first we are taking a left, then we have to take a right, again a left and again a right. So total we are covering four edges. Okay, four edges, and if you see count the nodes, it will be around five nodes. So 5 minus 1, 4 is the answer. Okay, either you can do number of nodes minus 1 or you can do number of edges traversed. Okay, in this case 4. Take any other node, you definitely won't be able to do it, because see, if I take from the root itself, if I take a right, I am forced to stop there itself, right? Similarly, from anywhere else, if you do, you will be forced to stop somewhere. You will never be able to cross more than 4. Okay, that is the idea. So by now, I think you will be clear what is zigzag. Zigzag means you can either start from a left or a right, whichever you want. But the next, see, if you have taken a left, you have to take a right compulsorily. Similarly, if you have taken a right, you have to take a left compulsorily. That is the idea. As long as you can are able to do, you should do, and then you will get the max length. Okay. So number of nodes travels minus one, or the total number of edges travels. That is going to be the answer. And coming to example 3, as I told you, I will be reminding you this thing when I come to example 3. Single node, if it is present, the answer, the length is going to be 0. Okay, because it defines the zigzag length as number of nodes traversed, number of nodes visited minus 1. So if a single node is visited, then it will be 1 minus 1, which is 0, right? That's why in this example, it is a single node. So 1 minus 1, which is 0. Okay. So that was all about it, and you can see minimum node is 1 and maximum node is 5 and 10 power 4. Okay, so at least a single node will be present in my solution. Okay, so now coming to the coding part of it, please be attentive because this is not going to be easy, right? Anything related to trees and graphs are not going to be easy to teach without a pen and paper, right? So the official solution given is a top-down approach. Okay, the official solution given is a top-down approach. I will show you that as well. It's simple one. You can follow that. That will be a much easier if you are a beginner. But if you want to learn either ways of it, okay, you can see this is very simple one, right? But if you want to learn the hardware way, okay, because in an interview maybe asked to code the other approach as well, right? See, the top down approach is simple, but in interview you may be asked to code the bottom up approach as well. Okay, so that's why I will show you how, what approach I have coded, taking myself into a situation where the interviewer is asking me to code a bottom up approach. Okay, so coming to my solution, I am declaring answer variable, which is going to be my final answer. Okay, and now this is the deface function. I am calling this deface function with my root. Okay, I am calling this with my root. Okay, so what will happen is I am declaring non-local answer. Non-local answer in Python, it means that take the answer variable, declare outside this function. Do not create a new variable inside the function. Okay. So this answer will refer to this answer variable. Okay, and they will updating at the same time. So what will happen is if I am at a root, if I am at a node for which both left and right child are none, I will return 0 comma 0. Okay, I will return 0 comma 0. That means for a leaf node, I will be returning 0 comma 0. Okay, and these are some of the values which I am declaring. Okay, R1, R2, L1, and L2. R1 and L1 will refer to the maximum path. Please note it down somewhere. R1 and L1 refers to the maximum path possible along the left and along the right for my right child. Okay, for my right child for the current node. R1 and L1 refers to the maximum length possible along the left or along the right for my right child. Similarly, R2 and L2. Okay, R2 and L2 refers to the maximum length possible for my left, maximum length possible along the left or along the right for my left child. Okay, please note it down somewhere. So initial, I am making initializing with minus one, because see, for if a root has do not have any child, I am returning 0 comma 0. So if a node doesn't even exist, so I will initialize them with minus one initially. Okay, because see, if say a node may not have a left node, okay, in that case their values will remain a minus one. Okay, otherwise they will be replaced here. Otherwise they will be replaced here. Okay, so that is the basic idea. See, if no like no children are there, you have to return 0 comma 0. If no left itself is not possible, you have to return minus 1 comma minus 1. Okay, that is the basic idea here. Okay, if my current node has a right child, okay, if my current node has a right child, okay, see, right child means I have to see one thing should be clear by now. They see, consider this one. If it has a right child, I have to consider the right child's left node. Okay, I have to consider the right child's left node. Okay, I cannot consider the right of it. So what I will do is see whatever right is coming, maybe that could have been the answer. That's why I will just compare the length coming from it. See, I am at 1 here. Okay, I am considering my right child currently. My right child will have either a path coming from its left or a path coming from its right. I cannot consider the path coming from its right further because this is itself is a right child, right? See, I am at 1. Okay, I am considering my right child. My right child will have two. See, either it could have a node coming from its left or it could have a root coming from its right. Only the root coming from its left, I have to consider further. Okay, I have to consider further. The root coming from its right, we will have to end there. Okay, whatever is the length that I have to consider, maybe that could have been the answer. So I will just consider it to find if it's greater than my max. Okay, so this was the idea. Please pause and rewind the video if you have any doubts, okay? Because I'm trying to cover each and every point out here, right? If you rewind the video, maybe not at once you will understand, but once you rewind and see, you will be able to understand it, okay? Second or third attempt. So I am at my right child, okay? I'm at my right child. I have called the deface function for my right child. It will return two values: the maximum root along its left, maximum root along its right. Okay, because it's already a right node. Okay, because it's already a right node, I only have to consider its left. Okay, I only have to consider its left. That's why I am going to consider its left only. You can clearly see that. Okay, L1 is being carried forward. R1 will not be carried forward. But R1 could have been the answer. That's why I will just decide to see if it is greater than my answer, current answer. If it is greater than my current answer, just make update my answer. Okay, R1 I cannot carry forward because of the, see, it has to be zigzag, right? I am at 1. I am considering my right child, which is okay, no dot right. Okay, I'm considering my right child, self dot right, yeah. And I have to now consider the path coming from its left only. Okay, I have to consider the path coming from its left. I cannot consider the path coming from its right. But there is a possibility that the path coming from the right could have been the answer. But see, it will end here. It cannot go further here. But maybe that have been the longest. That's why I will just try to compare it with my current answer. And if it is longer than that, I will update my current answer. Okay. And same is the case with my left. Okay. See, in case of left, what we will do? See, suppose this is my current node. Okay, the mouse pointer which is saying is my current node. I'm considering my left. Okay, it's I'm considering my left child as of now. What I have to do, I have to consider the left child's right only, because the only then it will be zigzag. Okay, I have to consider the left child's right only. Okay, so this is if my left child exists, I am calling a device function on that. It will return two things: it's left and it's right. Okay, it's left and it's right. I only have to consider its right. I cannot consider its left. Okay, but maybe the left could have been the answer. That's why I will just check if it's greater than my answer, current answer, and if it's greater than my current answer, I will just update my current answer. Okay. See, this is coming from my left, okay? This is the greatest node. See, I am at my left node, okay? My left node will have two things, something coming from its left and something coming from its right, path coming from its right. So this is going to be the largest path coming from its right, okay? But for my current node, it is coming from my left only. So it will come here, see R2 plus 1. See, that's what, it's slightly confusing. I understand that. But see, this is the best example I can show. I am at this one, okay? I am considering my left current, okay? My current left child, okay? My left child will have two things. One is the path coming from its left and the path coming from its right, okay? See, this is the longest path coming from its right. Take that. But see, for my current node, it is going to be still left only, okay? So this R is actually the right of my left child, but for the current child, it is going to be my left only. So I will write it in the left, in the, you can see left portion, and this will be in the right portion. Okay. I'm doing plus one to both the values because I have to take into consideration the current node as well. Okay. And will happen for every node except the root node. Okay. And finally, when we are coming, DFS of root I'm calling, and finally I am getting Alchem R. Okay. Alchem R is the maximum path, length path to its left and to its right. Okay. And finally, I'm taking the max of all these things. And finally, I'm returning the answer. You can clearly see when I run this code, it's clearing all test cases. It's around 88% faster than all the Python solutions. Okay, it's see, when we are talking about defense, the time constant O of n plus c, where n is the nodes and e is the number of edges, right? And same is going to be the space complexity. So yeah, friends, that was all for today. I know it's difficult thing. I will definitely give you the solution in the comment section. You can take this code and please run and see once how it works. Try to trace it, because see, following the official solution is one thing, but in because see, ultimately we are doing this to clear the interviews, right? In the interview, definitely, if you are able to solve one approach, you will be asked to code the other approach as well. And believe me, these questions are not hard. Okay, these are just medium level questions. Okay, you definitely can do it if you have a practice. I believe I have specialization in solving detailed questions. So please do reach out to me if you have any doubts. We can discuss further. Maybe you could point with some optimization, then I could optimize it further. Okay, that is my idea. So yeah, friends, please do contact me if you have any doubts and if you feel any optimization is possible here. Okay, that was all for today. Thanks a lot.